Hello everyone, I will be presenting the key features of our weather data app and demonstrate how it shows the data to our users. So here is the chart where the data will be presented. To get the data first, we need to select the start date and the end date. So I will be selecting the entire year of 2024. So the start date will be the 1st January and the end date will be the 31st of December. After that, I will be selecting the data source, which is IMD, and weather variable, the max temperature. We have to select a location on the map. Once I select the location on the map, we can see the data on the chart for that given location. If I select one more location on the map, so now we can see the data for from two different locations. We can also search for the location if we are not able to find it on the map. For example, I will search for Delhi, and then that pin will be added on the map and we can see the data for Delhi as well. We can then zoom in the map to see detail in a much clearer way. We can also compare the data from two data sources. For example, if I select NASA, we can see that we have multiple lines showing for the different location and their different data source. So we can compare the weather variable from the different data sources. If I select ERA5, now we will get the data from the IMD which we selected earlier and the ERA5, and we can compare those data sources. We can also export this chart as an image. So if I click on this button, so the chart will be saved as a image file. We can also export the data as CSV format, so we will get all the data for that location in CSV format. So you can see we have the data for those three different locations and their weather variables for the given date. You can perform year-over-year comparison of weather data for the selected location and time frame. And the user can also compare the year-over-year data with the 30-year climate normal for the selected location. If the user wants to retrieve data for multiple locations, they can upload a CSV file containing the coordinates of these locations. After uploading the CSV file, the user will be prompted to specify which fields corresponds to longitude and latitude. Next, the user selects the desired date range and data source and variable to retrieve. Upon submission, the system processes the CSV file and within a few minutes, the requested data will be ready to download in CSV format. The CSV file is ready. The user can download it and view the data for each coordinate across the selected dates, ensuring comprehensive coverage of all specified locations and time periods. The user can also upload shape files to retrieve data for a specific location. A shapefile upload consists of four files: the primary file containing the geometry along with the three supporting files that store associated data about the shapes. After uploading all four required files, the user will select the date range, data source, and data variable of interest. Additionally, the user can specify whether they want the data aggregated in a daily or weekly format. Once the input is submitted, the file are processed and data is extracted based on the geographic area defined by the shapefile. The resultant data is then stored into CSV file. The CSV file is ready for download. The user can download it and view the data associated with the location formatted according to their choice of daily or weekly aggregation. User can estimate crop yield using historical yield data combined with the selected weather variables for a given time period. To begin, the user uploads a sample yield dataset in CSV format containing multiple years of data for a specific location. The system then analyzes the historical crop yield against the chosen weather parameters to generate yield prediction for the selected date range. Once the file is uploaded, the user will specify the columns containing latitude and longitude, define the start and end dates, and select the desired weather variables from the available data sources. After processing, the system will generate the predicted crop yield, which can be downloaded as a CSV file containing the results. Users can explore weather data across the country for any selected date, with the option to view it either at the state or district level. To start, they choose the date, data source, weather variable, and preferred boundary level. Once the selection is made, the system fetches and renders the data on an interactive map. Clicking on a specific region, users can view the corresponding value of the chosen weather variable. The boundary level can be easily switched from state to district, allowing for a more detailed localized view of the weather data. Users can also access a 7-day weather forecast for any chosen location. To this, they simply search for a location, select the desired result, and the forecast is displayed in interactive charts. Charts present different weather variables, allowing user to clearly visualize and understand the upcoming weather trends for the week. We have a user and role management module with two main features. The user management section allows administrators to create user accounts and assign roles to them. The role management section enables the creation of roles with specific permissions, providing flexible access control throughout the system.